What's this? Okay, this is just a quick volume check since I started the recording. We've got, I better check that the light is correct here, solid, okay. I should open the correct folder. There we go. Yeah, okay, okay. Minimize that, minimize that. No, leave that open. Did that run? Does it look right? Let's see. Please, oh please, oh please. Did that work? That worked. Okay, so I will fix that right after class. I don't have 115 seconds for 6 documents. Okay, I should just go through this one more time. That, yep. Okay. Mm-hmm. Should make the list here taller. Oh, we should use maybe some colors there. Why not? Yeah. Okay, 55 seconds. $36 seconds. I hope you're all doing well. Hope you had a relatively enjoyable weekend. I think the entire state got a decent amount of snow, so maybe you, I don't know, did you go outside and like compact the snow and make an ice sculpture or something? Something like that. 3, 2, 1, go. Okay, welcome back, folks. Yeah, so uploading, transferring files for exam 2 took a lot longer than I thought it would, and there was like cases of like not one PDF submitted by a person, but rather four, and Gradescope can't do anything other than take a single PDF. So yeah, on the office computer, I've got a way to stitch together several PDFs together. Here, I had to be creative, so it was quite a process. I'm sorry for how long it took, and I think I will think of things like maybe just a direct upload to Gradescope for Exam 3 to make things a little smoother and just quicker. I hope that that process that would not involve not at least a significant extra amount of time for you, but I think it'll save a lot overall so that you can get things back a little quicker than that. Um, anyway, this is a normal, in quotes, week, I guess, with a quiz on Tuesday, though due up to Wednesday if you need it, just recognizing people's schedules. Wednesday response and Thursday homework. So kind of the more usual due dates. I feel like we never really got a chance to get in the rhythm of things. Today, though, uh, we will do a little review. Technically, nothing being said today or tomorrow is new. I hope what you're going to see, though, today is clarifying a lot of things. I hope you'll get this sense that today's main goal is like, how should you really think about things so that you can recall all of the things that occur here. So first off, the order I'm going to mention some things in is a little strange, but given a function f whose domain is x and codomain is y, the range of the function is there's other ways to write this that are better for proof, but I think it's much easier to think about like the running through, right? Think about it. Like as you run through each thing in capital X, and I gotta name it something right now, so let's call it little s, and you apply f. to that little s. So this is like all the outputs that you could possibly get, right? I think this is a very, very natural, like I'm not memorizing this thing one symbol at a time. In fact, you saw that I drew this part over here first because that's what I tend to think about first in that, not just in this notation, but in just what's going on with range. Everything in the domain ends up, you look at all the outputs, right? So I want these definitions to be really memorable, not from a memorization standpoint, but from a like, yeah, that's natural, that makes sense kind of standpoint. Another item on this list of like 6 things is if you have M that belongs to the domain, then f of M is an element of y, right? And that just comes from, I think it was part 1. Yeah, part 1 of the definition is that if you have something in the domain and you apply f to it, you should get something that's in the codomain. The things that I think tend to get people, and I'm going to focus less on the names of these right now and maybe more on the notation because I think this is where the confusion comes up. Let's say you have a subset of the domain. Let's call it capital S for right now. If you've got that, then the image of S is this is, as you run through each thing in this set, capital S, let's call that little s again, you apply f to it. So look at how similar this definition is the one to the one that's 2 lines above, right? So this definition here, this definition there. Do you see, like, you're doing f of s, it's just, does s run through each element of capital X or does s run through each element of capital S? Both of these, from how they're written and due to the fact that, as we said in the middle line here, every time you do f of something you get something in y, these should kind of, I hope these speak to you that these are both are subsets of your codomain. In this case that's called y, right? Again, I'm worried less about the names of some of these things. This next one we're going to look at is preimage, but again, it's not right now. I want to focus less on the name and just like the notation sometimes tends to get people. So if you have a subset of the codomain, right? So look, subset of codomain. So codomain, that's like the output stuff, right? Like there's this promise, this guarantee that every element that you apply f to, you get something in the codomain. So think about z as being some set of outputs. That's the idea. Not a set of inputs, but a set of outputs. Then the preimage of z is, we'll include here this x in capital X for clarity. We have done that before. But this is, there exists c in z such that f of x is equal to c. And just, I want you to focus less about trying to memorize this thing word for word. Like, oh, there's some chat going on here that I didn't look at until now. So, can you just, so in a proof, when you have f from x to y, can you just infer, can you just use all of these bullet points? Yeah, these are all definitions. These, what we're going through right now, these are all I'm just trying to review these definitions. So, yes, I mean, you've got to apply definitions. Otherwise, what the heck does something like f to the -1 and then z, capital Z in parentheses mean? This is reviewing the definition for what it means. So, even here, the thing that I'm thinking about is, look, you've got a set of some, outputs, and you're asking this -1. I want you to think about it like going backwards, right? So you've got some outputs. Like you're asking which inputs lead to those outputs. That's the short version of what's going on anyway. So if you really think about it, if this is a set of outputs, you see why you've got a little c that belongs to that set of outputs. You see why it's a c by right here by itself. There's no f of c. That would make no sense at all to do f of c, right? Because c should be an output. This is the kind of thing where I think people just try to memorize, one symbol at a time. And they're trying to memorize this long thing and treat this like something meaningless instead of thinking more from a standpoint of, oh yeah, I've got a set of outputs. Which inputs give me those outputs? One last one. And so I know the order of this is all strange, but if you just have an element of the codomain, then we can talk preimage too. So the difference between this line and that line um, so far is, do you have a subset of the codomain or do you have an element of the codomain? In fact, I had bounced back and forth between replacing the Z here and the C here both with just a star, but decided against it. I made the change in my notes and I changed it back for a reason I'll explain perhaps later at some point. But now that we're just dealing with one element in the codomain, we don't need all this quantifier business, so it just ends up being that. So I just wrote it, sorry for all the extra space, but I wrote it in this way to try to align. Like the bottom one, this is the one that we think of really first. It's which x is in the domain would you apply f to get c as your output. And then this line above is meant to be like the slightly more flexible version of it, where it's like not just one output, but maybe you have a set of outputs. That's all that's going on. Both of these, based on how they're written, they're in that set builder with criterion notation, but you see that since they both start with x and x, these you can see are both subsets of the domain. Right? So I tried to point with arrows. I think it's fairly clear already that due to the set notation that these are sets, but I think it's more important right now not just say, oh, these are sets. Think of what they are subsets of. Please don't try to memorize any of these. Don't memorize. I want you to understand. I want you to, get at what they're trying to say, right? So think about what these mean instead. And if you think about what these mean, for instance, like I want you to focus, for instance, in the second to last definition, on this part first. And then once you think about that part, then you can think, oh, well, there's this C being used that's not anywhere else in there yet, so I'm going to have to quantify it, and then you can think about if it needs to be a there exists or a for all later. It's like the same business early on in the semester, how I wanted you to think about the definition of divides. You think of the equation first, and then you go back and you feel, wait, oh, that's got to be a there exists on that, the k or whatever variable you use, right, instead of a for all. It's the same idea here. I want you to think about this in a more intuitive fashion than trying to memorize these. Now, I'm going to do something rather unique today that I've never tried with this topic, but here's why I'm doing it. I recognize that the four definitions that end up being sets here are the most confusing. They are. Now, I'm going to let you know that last semester I had people who played victim. If it's one thing this week, okay, but I had people last semester who week after week after week, there was always a question about the topics of images and preimages, and still didn't know the definitions and didn't bother asking in office hours or otherwise in class or any time, like, how do I think about these or anything. They just said, oh, these are hard, and then just kind of refused to do any of the problems and said this homework is unfair. And I'd say, look, first of all, we reviewed all these things already last week. There's this extra day of reviewing these things. So I don't want anybody to play this game of, oh, these are so hard that I can't do these. Let's go from a standpoint of, these are challenging. Let's attack these things and figure these things out. So here's what I'm going to do. I'm going to say for let's not draw a picture of range, because that is the most, it can be done, but I want to take actually all the rest of these four items there, and we're going to draw a picture. I'm going to model the first one for you. And what I'm suggesting is that you draw a big circle called X, and you draw Y like this. Now, this is sort of Venn diagrammy in approach. Now, X and Y might even be the same set, or they might be completely disjoint from each other. In other words, the intersection is, of course, defined, but maybe the empty set. You don't know. So we'll just draw these as two separate things right now. And so the first one here, if M is an X, so I'm just trying to draw a little m there. That one dot represents an element in capital X. And then when you apply F to it, you get, so this is applying F, and then you end up with this thingy over here, and this is F of M. So what I'm going to ask you to do, I'm going to pause for a moment, but I want you to attempt to draw a picture of, if you have a subset of X, then what should a cartoon of F of S. Again, so I shouldn't even call it that. What should a cartoon of the image look like? And you've got plenty of space in here to maybe draw some of the things you need to. And then do the same with the next one and the next one after that. So please work on drawing within this one picture a cartoon of these three things. So I'm going to wait about 2 minutes and then draw the first one, and then wait another minute and draw the next one, and wait another minute and draw the next one. Okay, so for the first one, you have a subset of X, and so I'm just going to kind of draw. So this is the reason I wanted different letters in each bullet point, so that, like in the picture, without having to say a lot, it'd be clear which thing we're talking about. So if you have a subset of X, maybe this subset might be the empty set, but I'm just going to draw a cartoon that has like three. The cardinality of S is three. Just in my cartoon, yours might look different, and so then. What's the image? Well, if you look at how the set is defined up there, it's just that each of these should go to elements of y. And maybe you didn't do this in your picture, but it could be the case that two of the elements go to the same output. So in my case here, my image only has 2 dots instead of 3. You might have 3. You might have not started with 3. That's fine, right? But I hope this cartoon gives you a sense of what the image looks like. But then look at the next one. Look where it starts. Z subset of Y. So why don't you start over here? Right? Maybe we'll draw 3 dots again or something like that. I don't know. I will pause and give you a moment to draw. So if you look back to the way things were defined, so preimage of z, so there exists a c in z, meaning each of these would be like the little c's, for the moment that they are, such that f of a thing from capital X is equal to c. So this is really just saying back here, maybe you've got this thingy, and when you apply f, you get c. And then you've got this element over here. When you apply f, you get c. Actually, you might even have the case that this other input, when you apply f, you might get to that same element of capital Z. And then maybe there's a fourth thing over here. When you apply f, you get there, right? So in each of these cases, these arrows are trying to talk about applying the function f. So this might be what a cartoon version of that preimage might look like. Lastly, you have just an element, little c in capital Y. So here, just for the element, is a cartoon. It's just a little cartoon. All of the elements I'm just drawing as dots, and the sets are like ovals that have dots in them. Right. So preimage of C. So go back up here and look. Right? So this should be all the x's that when you apply f, you would get c. And there might only be one, but there might be more than one. So I think it's more illustrative or helpful in our picture if I say we have a situation, maybe the function we have has two different outputs that lead to that, two different inputs that lead to that output c. And so then this would be a picture of preimage of c. Is this making sense? Are we? I would look for people to give me a that or a type a thumbs up or something, you know? Um, I want you to have the definitions up here for sure, yeah, be able to recite them, but I want them to lead to this. And if there's a disconnect between these two things, you've got to keep like wrestling with this and look at an example and so on. So, um, how are we doing? I hope we're doing okay. Let's practice. So, look at definitely the official definitions, or rather their review up here. Look at this picture as a helpful way, like make sure that these are saying the same thing, but I'd like to ask you to please look at the following function. So domain and codomain are both reals. The function rule is x squared plus 10. So I'd like you to please work out what is the range and write this in as nice of a format as possible, meaning if all you do is you write f of x, where x is in reals, well, as true as this is, as much as it copies what we saw earlier, it doesn't really process anything about this function. So what I mean just to model this is, in this case, if you run through your head all of the reals, like let me just actually write even more steps than I was intending to. F of x part here we can replace with x squared plus 10. So as x runs through reals. And then here I want you to use your algebra and arithmetic skills and go, okay, if I run through every possible real number in my head and square it and add 10, then in summary the numbers I get are 10 to infinity, including 10, right? Like I want you to get to this stage instead of leaving it just generic. Because the generic thing doesn't allow you to really process the rule. It's it would be too much just copying the notation from above and just replacing things. So like get to this stage, even if you write out this work or choose to skip writing it out. So I've got a couple more of this kind of thing for you. So just to practice the various definitions, find f of 3. Okay, that's the easy one. But then if capital S is the set singleton 5, union the interval 9 to 10, find image. Find if Z is the set 46 comma 74, find preimage of this Z. If Z is the singleton set 19, then find preimage of Z. And if C is equal to the number 19, find preimage of C. And one more. I'm going to scroll down one bit, sorry. If C is equal to 2, find preimage of C. So why don't you fill in best as you can those details. Oh yeah, f of 3 here as well. So maybe I'll just, so that if you need to refer to the various parts, I'm going to, it's not in my notes this way, but makes part A, B, C, D, E, F, G. Might make it easier to talk about if you wanted to kind of point. Okay, so first of all, part B, f of 3. Well, that's the 3 squared plus 10, 19, right? So that's the college algebra question. Now we move on to the real, questions that will allow us to exercise these definitions. So you got this set S. It consists of just the number 5 and then all real numbers between 9 and 10 as well. So it's kind of a strange, peculiar looking set, right? If you drew it on a number line, it's like a single point followed by an interval later, something like that. But I don't even want to call that f of s, but I know that's what it looks like notation wise. But we're going forward, if you will, right? So this is saying if you look at 5 as an input and then like 9.1 and 9.3 and 10.0 and 9.8 and so on as inputs, and you apply f, what kind of numbers do you get as output? Well, you get 25. That's kind of a one number that you get on its 35, right? Oops. Yeah, there's this plus 10. You get that number. In addition, you also get, it's 81 plus 10, 91, 100 through 110. All those real numbers you get as well. What about for part D? Preimage of the set consisting of 46 and 74. This set is actually so tiny, its cardinality is rather small. I would just prefer to write down all the elements individually. Now, look, this is a subset of the codomain. If you're curious which of course Z is a subset of the domain reals, but since we're doing preimage, if I scroll up for a moment, we are applying this definition here. Right? And so the thing is, the only time we include an x is if there exists a thing in z, in not the double-lined integer z, this z down there. So is there an element of domain? We were going to write down over here any elements of the domain where there exists an element of that set, meaning one of those two numbers, where when you apply f, you get one of those two numbers. So who's got an element of the preimage of z in part D that they would like to share? Six. Okay, I agree that 6 belongs in this set, right? Because there exists an element there exists a c in here in 46 comma 74 such that f of 6 equals c. Any other? Oh, we've got a negative 6 as well. Okay, yeah, I agree that negative 6 is in here. Anything else? 8. I'm sure somebody will bring up a negative 8, and that'll do it, right? So these are the 4 elements of this preimage. Of course, it can be written in a more generic form, but I think to process what's really happening and to look at incorporating the rule, I think this is perhaps the nicest way to do this. For the next one, we're asking what elements of the domain have the property that there exists an element in this set Z. I know there's only one element of that set. But the question format should be the same as the previous one, and it turns out then there should be a 3 and a negative 3 there. The next one, part F, is the other preimage definition. It's preimage of just a single element of the codomain, but that ends up being 3, negative 3 as well. Right, so this one's actually easier to deal with because there's no quantifier issue floating around and so on. The last one. So what about 2? The question, see, I hope what you're already seeing is even in part F, this thing is, it's like if 19 is the output, what inputs make that happen? Right? And the inputs is a set of inputs. It was 3 and negative 3. And now the question is if the output is 2, what inputs make that happen? You see how nice and very natural it is if you just formulate the language like that? What inputs make the output 2 happen here? And it turns out that there's nothing, right? So you can't get 2 as an output no matter which real number you use if your rule is x squared plus 10. So the set we get here, we always get a set, by the way. It's the empty set, right? So I maintain what I said up here. You always get a subset of the domain. In this case, whether you write it that just two curly braces right after each other or a zero with a slash through it, what you have is that. So I hope we're okay with this exercise. I know it takes up time to do it this way in class, but I think it's important to make this active and you know keep a picture like this in your mind. Allow the picture to help recreate the definition instead of just saying, "Oh, the definitions are hard, so I just won't expect myself to know them." Like that's not gonna work. Um, let's take a look at the function f from reals for reals. Uh, let's see. I see a little error in my notes. It should be a little g. So say that g of x has rule cosine of x. So there's my domain codomain rule. I'm going to just mention a couple things for you here. That the range is -1 to 1. That g of pi over 2, so cosine of the 90-degree angle, or the x-coordinate on the unit circle there, should be 0. And I just want to note that 0 is in the codomain. I'm writing codomain out in words instead of just r, because both domain and codomain are r. I will comment that if you do, this is the same idea as the previous example, just without as much notation. So let's say you look at the image of the following set: 0, pi over 6, pi over 4. I mean, this is essentially just asking us to cosine each of these three angles and see what you get. And so you get the set consisting of 1, root 3 over 2, and root 2 over 2. If you instead looked at g, and you looked at the image of another set, so not a set of just three numbers, but of all the angles from 0 to pi over 2, think about it. So all angles now from 0 to pi, all of them, right? Not just like whole number degrees or whatever. You look at the x-coordinate of all those points on the unit circle. I think you get all x values between 0 and 1. None of the negative values. So I think you get that. Right? If you look at the preimage of -1 to 1, again, we just dealt with preimage of a set. So what we're asking is, take this set, -1 to 1. So all those numbers between -1 and 1. Maybe you're thinking of the number 0.6 or 0.81 or whatever, right? Like maybe you're thinking of -0.5. So look at all of those numbers as outputs, and we ask what inputs would give us any of those outputs, right? What numbers in this domain R that I just put an arrow at could we apply g to end up getting a number that is between -1 and 1? Well, if you think of how the graph of cosine goes, every real number you take a cosine of ends up being an output between -1 and 1. So this time, the subset of the domain we get is all of the domain. If you look at the preimage of a single element of the codomain, right? Again, with the g to the -1 business, we should think of this 0 as belonging to this R, right? To the codomain. We're asking right now, what inputs have 0 as an output? Now, if you keep in mind that cosine is periodic, you actually get 0 as an output for cosine quite often. So it's actually most natural to describe this set in the following format. As you run through each integer, you could start at pi over 2 and add an integer multiple of pi at a time. If you looked at the preimage of 1.1, so I picked 1.1 belonging to this codomain reals again. We're asking what inputs have output 1.1, and there are none, so that here again we get the empty set. So I hope this is also okay for clarifying sort of all the more confusing definitions of last week. Okay, then want to remind you that we had this definition. So I'll review still. Let f be a bijective function. Be bijective. I'll write it a little differently from last time. Then the inverse function. F to the -1 is what it looks like. So you've seen this notation f to the -1 earlier in class today, but up until now it has not referred to inverse function at all until this moment. I cannot stress this enough. People all I know the notation looks confusing. It's an unfortunate, terrible inconsistency of notation. That said, you need to sort this out all the time, every time, and look at what you have and go, does it appear to be, if I don't have a bijective function, this definition is out completely. Forget about it. That said, even if you have a bijective function, if it looks like you're applying this to, you're doing this of a set, like a z as we had above, you should be thinking of preimage. Okay, so let's see. So inverse function is the inverse function has rule. So written as a set, this is ordered pair yx when the as you run through ordered pairs xy that belong to f. The whole point, so this is written a little differently from the past, but the whole point, the key idea here is the one that you know from the past, is that f of x is equal to y if and only if f inverse of y is equal to x, right? Kind of usual story if you got to swap the input and output. Okay, this is only defined when you have a bijective function. Okay, otherwise you don't have a, you can only do this when you have a bijective function. So just to do this, and this is a key kind of point that gets people. So the function we just looked at earlier, from reals to reals with rule cosine of x, this is not bijective. Right? This function is not injective. It's very periodic and not surjective either. So it's neither when it needed to be both to be bijective. So there is no inverse function. No inverse function. I just see question. Sorry about I was not looking up at my other screen here. Question. So the difference is determined by context. That's a good. I don't know that I would say necessarily that the difference is determined by context so much. In a short answer, yeah, but I think the whole point is when you see this, if by context, I mean if you know that f is bijective, then you can always interpret this notation to mean the inverse function. If you don't know if your function is bijective, so question mark, then the only way you can interpret this f to the -1 notation is as a preimage. There are times when you can interpret this notation both ways, right? So if you know you have a bijective function, then this notation can refer to preimage as it always does for any function, or it can refer to just the name of this new inverse function as it's called, and that's how this notation is being used here. In that case, you're going to get two slightly different technically different answers, but we're going to sort that out. Yeah, so is it going to be inverse? Is it going to be preimage? In one slim context, you get to interpret it both ways, and you get two slightly different looking answers that morally have the same information. And we will see an example of this by the end of class today. Okay, so the thing is, maybe we want to change this. If we change this instead, the codomain to be -1 to 1, at least we'll get the surjective part, but we wouldn't get injective. So we've got to really fix things up if we're going to get a function that's bijective. So I've called this thing k and made the domain 0 to pi. It's like the most appropriate set to use as the domain for cosine. So this function, k of x with rule cosine of x, now the domain and codomain have both been chopped. This is bijective. So then the inverse. So then there exists this inverse function. So k inverse, switch the domain and codomains around. And then the point is with rule, the usual language is like k inverse of whatever z is equal to arc cosine of z. Okay, so this context thing to talk about here is perhaps this note now that if f from a to b is bijective, then this notation, I don't even want to say anything about it, right? This thingy is a set as before. What I mean by as before is we said for any function f, without saying whether the function is bijective or not, any function you can look at this and then apply the definition of preimage. And if you apply the definition of preimage, I'm going to scroll to the top. Sorry if I hope this doesn't make you dizzy or anything like that. Both definitions of preimage, the one I'm looking at, those actually right here, but both of them are subsets of the domain. So I'm going to scroll back down. So we can interpret this as a subset of the domain, as we did before, but also as a new way, we can also, because we have a bijective function, we've got this, we can also say that this is an element of A. So y is an element of A because the inverse function, you've got to swap where the A and B are, so this should be from B to A. So I think this, what I'm trying to get at is there's these two approaches here, right? So if f is bijective, there are two meanings of this notation. Otherwise, there's only one. Otherwise, only one. And if you don't have a bijective function, or you don't know that your function is bijective, you have to use the definition of preimage, and that's the end of the story there. So what I'd like to do is contrast these ideas by looking at two examples side by side. So I've got f from reals to reals with rule 3x plus 2. I've got another example, g, a function from reals to reals with rule g of x is equal to x cubed minus 3x. The first of these is a y equals mx plus b, right? Intercept y-intercept 2, slope 3. That's a line. I'm just trying to say, I hope from the, we're not going to prove anything right now. That's not the point. But this function is both injective and surjective. Injective, horizontal line test passes. Surjective, every real number is an output. Every real number ends up as a y value. The other function, just in a super quick sketch, looks like this. Okay. Point being, this function g on the right is it may be surjective, it is, but it's not injective, right? So this f here is injective and surjective. Okay, so this function f is bijective, and an inverse exists and all this business. Over here, g is surjective, but not injective. The horizontal line test fails, right? So not bijective. If we just look at a couple quick computations, first, f of 10 is 32, g of 10, I'll spare you the arithmetic, is 970 in a calculator. We'll apply the image definition. So when you have a subset of the domain, this is just asking what outputs. So apply f to each of the elements of the set, and then what do you get? And you get this set. Well, 32 we already knew, but then we also, because we're looking at input 11 as well, get output 35. So just a set, collecting both of those outputs together, right? This is a subset of the codomain. Same deal over here. If we did practice the same definition, what happens when you take g and you apply it to both 0 and to 1, you end up with 0 and you get negative 2. Now, let's look at this. Okay. one possible interpretation of what's going on here is preimage. In other words, we should, as preimage always does, create a subset. I already drew a curly brace. A subset of the domain, right? So we're creating right now a subset of R, and I'll just point, sorry, this is getting messy, that R, the domain R. And so the question I'm asking is what input or what inputs would lead to 5 as an output? And the only one that will do this is input 1, right? Based on the rule 3x plus 2. And if you look over here, preimage of 970, again we get a set. Now, based on the way this graph is drawn, this point is not that high up. In fact, I have it in my notes that this point is -1, comma 2. I mean, I got to done some calculus, take derivative set equal to 0. The point is 970 as an output is way up here somewhere, and we're only going to get, 970. We're only going to get one output here, or one input that leads to this, and it is going to be the 10 that we already knew about from right up there. Now, the point is, in what's written both right here and right here, do not say or think inverse. I didn't say or think inverse. So this is not inverse. Not inverse. Inverse never entered the discussion, right? In both cases here, we were talking about preimage. So this is always a subset of domain. Now, to address the key thing here, though, is to say, but this f is bijective. And so we have a new interpretation, right? So there's this inverse function. So we have, you got to switch the r and the r, right? So up above, I'll scroll up a little bit, it was reals to reals, so if you switch the two, you have reals to reals. And I won't work this detail out right now, but this function, the rule for this function is, so first of all, the name of the function was f inverse, and I'll just use c as the name of the input variable. It ends up being c minus 2 over 3. If you want to ask where I got that, let's save that for another time, but it's finding the formula for an inverse function, swap x and y and solve for the other variable. So you've done this in the past. It might have been a while ago. So the point is, with this, we could say f to the -1 now is the name of the inverse function, apply 5 as an input, and now we're looking up here, and so what we end up with is 5 minus 2 over 3, or we get 1. We get the number 1, right? So here I'm saying we say or we think inverse. Above in blue, we don't. So if you take a look at, maybe I'll circle this in green, take a look at our two answers. We have the preimage ends up being the set with one number, which happens to be 1, and then applying the inverse function to input 5 ends up being not a set. It ends up being a number 1. So both of these are considered correct answers to this question. However, I'll do this in red, you cannot, this is not okay, grumpy cat, if you, oh, cat, there, if you do this. If you think G inverse, there is no G inverse. It does not exist. You cannot write this. Over here, you have to have set notation. So, I have a worksheet. Normally, I would have printed it out for you. I'm going to push this onto the other screen and allow you to work on things and ask questions, whether allowed. Is this large enough? Maybe I can do this. So there's at least parts 1, 2, 3 here, with each of those has subparts A, B, C, D, E, F, G, but there's more to the worksheet. So I'll just leave it here on this screen for a couple moments, and then, oh, actually I did open it in another PDF viewer. So can you work on this and Everything's numbered, so if you wanted to talk about a part of a question, you can do that, and you can unmute a mic to ask a question, or you can write a private chat room comment or something. I can see everything. Okay. And what I'll do, since there is a little space, oh dear, is I'm gonna do that. Oh, that's not that brilliant here, is it? Yeah, that'll kind of work. Do you like my set capital E? So I have no idea how they get away with it, but there is a Simpsons package for tech. I have no idea how like the intellectual property rights on that work. Was a LaTeX code for that? Yeah, good question. Let me just instead of writing it on screen. Well, I guess I could do this here. This Xodo, as you can kind of see up in the corner, is a free PDF writing tool. So, first of all, you got to do a use package. Oh, my handwriting looks different in it, but it's acceptable. In Acrobat, doesn't work at all. So it's Simpson or Simpsons. I forget if it's plural or singular. Once you've added the package, you just do backslash Lisa with a capital L. And there's also a Homer and a Marge and a Maggie and a Bart. Please don't throw these all over your homework assignments now, because they do take up a lot of space, don't they? Or you can. Anyway, yeah, try the thing here. So in each case, you'll notice parts F and G only apply if you have a bijective function. So that's why in part E, even though it looks like to the whatever function to the -1 of 5, I don't want you to think of it like inverse function. I want you to think about it in part E as preimage, the only definition that always applies. So as happens in class, I tend to just walk around, and if you wanted to double check on an answer and you didn't even want other people to hear, you could type it into the chat and go, for part, B on question 2, is this right? You can do that kind of thing. For 1D, you did ask everyone, so everybody should be able to see your comment. So thought I'd just answer for everyone here. 1D is this going to be the empty set? Let's see, W14. Well, this is not preimage though, right? So if you were talking about, so if we saw this, then we'd be talking about what inputs lead to an output that belongs to the set here. And then you'd have the empty set. But over here, this is forwards, if I can use that kind of informal language. So I don't think you get the empty set. The definition to be looking at for that one is this. How do I highlight this one? Right? Because there's no to the -1 notation. We should be thinking of a subset of the domain. I hope that clears it up. Let me minimize this. Oh yeah, okay, cool. Missed that it wasn't up. Yeah. Getting too excited about like, I gotta practice all them, I gotta pre-image all the things! And then, the question was asking image. Okay, I've got 25 seconds, so I'll go ahead and just do a round of announcements to say, as usual, hey, there's a homework due Thursday, but don't start it too late. Don't start like Tuesday night or Wednesday night for sure. Like, I hope you've already started. I hope whenever a homework is due on Thursday, you already turn it in. Regarding the exam, please be careful, folks, on how you prove and use certain things, like what it means for one set to be a subset of another. I think those are the kinds of confusions that sometimes tend to come out of the process of an exam. And I will say that tomorrow is meant to be another review of this stuff, like just to try to pick at some of the other things that I think tend to be confusing. And I will say the following. I know this stuff is strange at first, but you've got to like really force yourself to get used to it instead of just playing victim to, oh, this is just hard and I'm going to call it a day. We spent all of last week, all 4 classes last week, talking about functions. Today, tomorrow are to review the more difficult parts. And then we have to have this stuff super solid, like, I mean, completely solid for the next topic. The next topic is, I think, the thing that students tend to find the most difficult. But where do things break down? It's people have a misunderstanding about functions. So make sure this stuff is clear. All right, I will see you for office hours or for class tomorrow.